So here goes our first try at a video. We're going to do properties of logs. So the first property is going to be the log base b of x plus the log base b of y is now going to be equal to the log base b of x times y. So the argument is now multiplied as a single logarithm here. Likewise, when you have subtraction, it's going to be division in the argument. So basically we're taking two logs, whether add or subtract, and we're writing it as a single logarithm. Probably the most important one is this one with the exponent. So this exponent m is now going to be the coefficient in the logarithm here. So there are a bunch of proofs that go with each of these logs, but for time purposes, I think we're just going to stick with the properties themselves. The properties go both ways. So when you have a division here, you can write it as two separate logs if need be with a subtraction, and the same thing with the multiplication. You can write it as two separate logs with addition. But most of the time they're writing it as a single log. This one does go back and forth quite a bit. The m can be now the exponent, or the exponent becomes the coefficient. So I'm going to do 4 examples. Here's example 1. So this is a addition problem here. So we can write this as a single log base 2 of 20x, that is multiplying the 4x and the 5. And if you remember from last week, I mentioned there are two types of log problems. One where the logs are equal to each other, therefore the arguments are equal, which is this problem. And we'll get x equals 2. But we do need to check our answers. The other log problem we'll do in just a moment, where it will be a log equal to a number, and we can use the counterclockwise rotation. But this problem has two logs equal to each other, therefore the arguments are equal, and we get x equals 2. We do need to check to make sure there's no undefined things that take place when we substitute the number back in. In this case, we're going to get 8 right here when we substitute 2 in for x. And it does check. Problem number 2. This one is another addition, so we can write it as a single log. We are going to have to distribute the a, so it becomes a squared plus 21a equals 2. So here's the other type of problem where it's a logarithm equal to a number. We have the counterclockwise. So we have 10 squared equal to a squared plus 21a. But to simplify that better, it would be a squared plus 21a minus 100 equals 0. So we're going to set it equal to 0, simplifying that expression to make it a quadratic. This one is factorable. It's a plus 25, a minus 4. So we have two solutions of negative 25, positive 4. But when those two get substituted back in, right away you'll notice that when negative 25 is here, we're going to have a negative argument. And same thing here, we'll have a negative argument. But when 4 is substituted in, it does work. So we have basically one solution. This one's extraneous. The answer is 4. Problem number 3. This one's kind of a long one. I got it out of the book. Notice there's a subtraction and addition, but it's going to be a log equals a log. So we want to take the left side of the equation and make it a single log. The division right here is actually going to be 64 divided by 8 over 3 as a single log, base 7. And if you remember, 64 divided by a fraction is the same as multiplied by the reciprocal. So this actually simplifies to 24. So this is log base 7 of 24, and it is still plus log base 7 of 2. Of course, it equals the right side of the equation. And with the addition, we can write it as a single log of multiplying 24 times 2, or 48. And now we have the arguments equal to each other. And we get x equals 12. When 12 is substituted back in, it's only substituted back in right here. It's not going to give us an undefined situation with logarithms, so this checks as the final answer. This last example has the coefficients, so I'm going to rewrite this one as the log base 10 of 512. That is 8 raised to the third power, so the 3 goes right there. Okay, so that's where the 512 comes in. This 1/2 goes right here, so that's actually the square root of 36. So it's minus log base 10 of 6. And then we have a division. We're now going to take 512 and divide it by 6, which gives us 85 1/3, or 85.3 repeating. And then the arguments are equal, so the answer is 85.3 repeating, or 85 1/3. And when that's substituted right here, it does check. So hopefully this helps for lesson 7.5. Tomorrow I'll put a lesson on for 7.6, and I'm hoping that this is the way things are going to go for lessons. I'll even do chapter 8 next week, and we'll try to get through as much as we can doing these lessons. I hope this was helpful. Have a good day.